All right, here's the first page of this IB Apps Chapter 2 review. You've got a flat horizontal area such that A to B is 100, B to C is 50, and angle ACB is 43.7, as shown in the diagram. Show that the angle BAC is 20.2 degrees. So BAC is 20.2 degrees. So since A is in the middle of these three letters, our angle here is A. So we need to prove that this is 20.2 degrees. So I'm going to use the law of sine because I can use the ratio of the opposite sides and the opposite angles to figure this out. So we've got this opposite side and this angle, and we've got this side and its opposite angle. So let's write this out. So we've got sine of 43.7 degrees over 100 equals sine, I'm just going to call it angle A, over the length, which is 50, and then we should be able to figure out the missing angle. So we've got this ratio and this ratio, so we can cross multiply, and when we cross multiply, we end up with 100 sine A equals 50 sine 43.7, and then I put this into my calculator, and first of all I can divide both sides by 100, and then I get sine A equals 0.5 sine 43.7, and then I get, so 0.5 times sine 43.7, and I get sine A equals 0.34544, and then I press on my calculator, I press second sine, so we're going to do the inverse, and we want to take this previous number, so second and the little negative button here to get the answer. So the inverse sine of that answer, and we hit enter, and we get the angle is 20.2 degrees. And we just showed, so whenever you see the words show, that means we have to do the work to show it. You can't just write the answer because they've already told you the answer. Okay, so calculate the area of the triangle. So I go back to my formula sheet and I say, okay, look, the area of a triangle is 1/2 AB sine C. So these are the angles on either side of the angle that we know. So remember, the capital letters represents the points, and the lowercase letters represent the sides across from the capital letter. So here we go. So the area, so we know these two sides here. We need to figure this angle first before we do anything. So in order to figure out that angle, I'm going to do add 20.2 plus 43.7, and we get and we get 63.9, and then 180 minus 63.9, and we get we get 116.1 degrees. So that means this angle here is 116.1. So 116.1, we know that's 50, we know that's 100, so now we can use our area formula, which is 1/2 the two sides of either angle, 100 times 50, and then we'll click our formula sheet again. It's sine of the angle in between the two. So this is angle C, and we've got this side and this side, and same thing here. So we've got this side, this side, and the angle in between. So sine 116.1, and now we can figure out the area. So we get 0.5 times 100 times 50 sine 116.1, and then I hit enter, and we figure out that the area of the triangle is equal to 2245.0689 ... So if I want to do it in 3 significant figures, the area of the triangle is 2250. And what are the units? Up here it says meters, so I'm going to put this in meters, and area is represented in meters squared. Okay, you may want to hit pause if you need to copy this down. Find the length of AC. So if I know this is 116.1, then I can do the law of sines again, because they're trying to figure out this length, AC, and I know this angle. So let's write it out. So let's just call that x, right? Okay, so so sine 116.1 over x equals sine of 43.7 over 100, and now I can cross multiply, and I end up with x times sine 43.7 equals 100 times sine 116.1. Divide both sides by sine 43.7. And then we get our answer. So 100 sine 116.1, close parentheses, divide by sine 43.7, close parentheses, and we get 129.98. So it's 129.98. And if we're rounding this to 3 significant figures, this 9 rounds up, so then this is going to be 130. And this is the length of a side, so it's going to be meters. Okay, now this next problem is quite challenging. Okay, a vertical pole TB is constructed at the point B and with a height of 25 meters. Calculate the angle of elevation of T from the midpoint to on the side of AC. So I'm going to redraw our triangle here. Okay, and we've got A, B, and C, and we want the midpoint between A and C. So I'm just going to call that M. And so we already know that this whole length here, the length of this line is 130. We just figured that out. So from the midpoint here, it's going to be half of 130. This is going to be 65 meters from here to here. Okay. Now, so we want to construct the line TB, which goes, it's a vertical pole. So right here, we're going to have a vertical pole. Okay. So think of it as going straight up, right? Okay. And this height is 25. And calculate the angle between T and the midpoint of side AC. So the midpoint of side AC, we know that from there is 65. We know this angle here is 43.7, and we need the length of MB. Okay, so the first thing we're going to do is find the length of MB. Okay, we know this is 50. So if I've got that side, if I've got these two sides and the angle in between, I could use the law of cosine. So I've got the angle in between, so I can say that BM squared is equal to, so here's the law of cosine. So the angle that's in between, we're trying to find this side across from it. So this side is going to be equal to the sides on either side of the yellow angle here, and each of them squared, minus 2 times the A and the B, and then cosine of this angle. So now we're going to put that into action here. So this length here is equal to 50 squared plus 65 squared minus 2 times 50 times 65, oops, and cosine of the angle 43.7. Okay, and then I put that into my calculator, and then I get BM squared equals 25.713, and then I take the square root of that, and I get the length of BM equals 45.0. Okay, so we're not done yet. So now if I turn this sideways here, we want this angle right here three-dimensionally. So I'm going to redraw this over here. So we've got from M to B, right? That's this red line here. And we've got our tower. Okay, here's our tower, right? And we know the tower has a height of 25 meters. Okay, and we just found out MB was 45. And we want to find the angle of elevation of T to M. So T is on the top from M. So the angle of elevation of T from M. So here's M, and we want to find out this angle elevation. I'm going to call it theta. Okay, the tower is at a right angle. It's not the leaning tower it's of Pisa, it's straight up and down. So we've got the opposite side, we've got the adjacent side, so we're going to use tangent. So I can say tangent of the angle is equal to the opposite over the adjacent, so is equal to 25 over 45. 25 divided by 45 gives us 25 divided by 45 gives us 0.5 repeating. Okay, so then I do second tan, second negative to get our answer, second tan, so inverse tangent of this value, and we get 29.05. So the angle is equal to 29.1 degrees. You may want to hit pause and copy this down or rewatch the video. Next page. Okay. The park in this form has these dimensions and this angle. Calculate the length of AC. So I'm just going to call that X, and we've got these two sides, and we have the angle in between. So when we've got two sides and the angle in between of them, you're going to use the cosine rule. So we're going to call this, we should call this lowercase b, right? So b squared is equal to a squared plus c squared minus 2ac cosine of angle b. Okay, so let's plug it in. So we've got x squared equals 62 squared plus 79 squared minus 2 times 62 times 79 cosine 52. You might want to hit pause for a second. Okay, so we put all of this into the calculator, and you end up with x squared equals 4053. Then we take the square root of that, and we get that AC is equal to 63.67087. So AC is approximately equal to 63.7, and we've got to put our units, kilometers. Okay. You might want to hit pause if you want to check your work. Okay, so that's the work for this problem here. And then the last one, calculate the area of the park. So the area of the park is equal to these two sides, it's equal to 1/2 times the sides on either side of the angle and sine of that angle. So we're going to have 1/2 either side of the triangle, which is 60. Let's zoom out a little bit. So 1/2 62 times 79 sine of that angle, 52. Put all that in the calculator. I end up with 1929.83 kilometers squared. And so to 3 significant figures, we get 1930 km squared. And that's the area of our triangle. The next parts of this activity will be on separate video.